Awesome. So here is part D, part 2, number 1. So it says calculate the volume of exactly 1 mole of a gas that is exactly 0.00 degrees Celsius and 1 atm of pressure. So for this, the way that we know we're going to use that ideal gas law is because it says 1 mole of a gas. So if it ever says moles or grams or some type of quantity of gas, we know we have to use Pervner, PV equals nRT, or the ideal gas law. So we have to identify all of these different variables, or at least 4 out of the 5. So we have P, V, N, R, and T, pressure, volume, moles, the gas constant, and temperature. The gas constant's always given to us. It's the same thing every time, liters per atm per Kelvin mole. So now let's go ahead and pull out everything else that the problem gave us. So calculate the volume, so there is our unknown, of exactly 1 mole, so that is our quantity, of a gas at exactly 0.00 degrees Celsius and 1 atm of pressure. So we have everything we need, but the one thing that you have to remember for this equation is you still have to convert it to Kelvin. So our temperature, we're going to go ahead and convert it to 273.15 Kelvin. We got it. So let's go ahead and plug it all in. For me, I'm going to go ahead and isolate V because I think that's going to be the easiest way to do it from the start. So right now we have pressure attached, which we don't want. So we're going to divide both sides by P. It cancels over on the left-hand side. Let's rewrite that equation. So volume equals moles times gas constant times temperature over pressure. So again, we just rewrote that equation, manipulated it to get volume by itself since that's what we're solving for. Let's plug it all in. We have 1.00 moles. The gas constant, 0.0821 liters atm per Kelvin mole. The temperature is 273.15 Kelvin. And then on the bottom, the pressure is 1.00 atm. Perfect. So let's go ahead and plug that into our calculator. We're going to say 1 times 0.0821 times 273.15. And anything divided by 1 is itself. So we'll go ahead and round it to 22.4 liters. So hopefully that number looks familiar. So this number we used a ton back in Unit 6 and in Unit 8. So with our mole conversions, we always said that 1 mole of a gas equals 22.4 liters at STP. So if you look at that problem a little more closely, you'll notice that these are the conditions for STP. And mathematically, using our ideal gas law, you'll see that it does equal 22.4 liters of that gas at STP. Very exciting. If we wanted to also take a look at those units, we can see that they all cancel. So we go from moles to moles, Kelvin to Kelvin, atm to atm, and then the only unit we're left with is liters, which is what is going to be the unit for our final answer.